Hi, in this demo I want to show you some new things we added in 3.1 for our cloud storage support. But for those of you not yet familiar with what SonarC2 and SonarG have from a cloud perspective, you have infinite retention on any of the big cloud platforms, so Amazon, Google, Microsoft, SoftLayer, and even on-prem clouds using OpenStack. And one of the things we do is we keep the data optimized on one of the storage layers. So for example, if I'm running this on AWS, some of the data could be on EBS, some of the data can be on S3, some of the data can be in Glacier. So all that's not new. What's new is the optimization levels that we can achieve, and what I'll show you today is um, just how fast things can be, even when things live on cloud storage through some of these optimizations. So what I have set up, I have an Amazon EC2 machine where I've installed the Sonar software, and I have the data sitting in two places. I have the data sitting on um, both on EBS um, and on um, S3, and I've kept the same data on both. So, for example, what I have from a local drive perspective, I have two EBS volumes over here. You can see they both each one is 2 terabytes, and they're configured um, as a RAID 0. So I'm making even better use of EBS because I can stripe the data and access the data in parallel from both drives. Each of the drives just has 6,000 IOPS, so they're not really provisioned IOPS to a very high level, but again, I have this RAID device. And on the other side, I just have the data also sitting on S3. Um, so what I'll do now is and what I've configured, if I go to the storage layer within SonarC2, I have these two collections. They are identical apart from the fact that one of them is local. So all local full SQL is a local collection, while full SQL over here, where is this? You can see the cloud, um, the little cloud icon, and that means that this is governed by a cloud policy, and it keeps the data on S3, S3IA, and Glacier. And I have the same data. The data is pretty simple. Um, what it looks like, there's a bunch of documents, right? I'll show you an example of a document. This is an example of a document that sits inside this collection, and in it there's a field called full SQL. And full SQL is just a big text field. In this case, it just has some SQL command, which can get very, very long. Some of these could have a few pages worth of SQL statements in one field. Now, again, because all the data is sitting in a column store, when I do a search, I don't actually need to bring back all the data. If I do a search on full SQL, for example, I only need to look at the full SQL column. So that's another reason why things are so fast when they run on the cloud in SonarC2. Okay, so now I'll go into kind of the setup that I've configured, and really what I'm doing is I'm going to show you what's actually happening on the device itself. So I'm not going to use the GUI. I'm just going to use a shell so that it's clear. And I'm going to run two queries. I'm going to run um, one query which is going to run on the local on the collection where all the data is local. So let me start it because it does take a while because I'm running this on a very large data set. Um, and so I'll just explain what I'm doing. But before I explain, what's important is this piece right now. Okay, so what you see here, I'm running IOStats over here, and what you see is that because this is a local collection, it's really churning the disk. You can see the percent utilization. DM0 is the RAID device. You can see I'm at 97% capacity. Okay, and it's reading, you can see down here, it's reading about at a rate of 240, 250 megabytes per second. So it's really hitting the disks very hard. Over here I'm running top. You can see that the data store is at about, it's using about 2.5 cores of the system. Again, everything that runs in Sonar is parallelized within every machine. You could, of course, have multiple nodes to speed it up even further. But for this case, really what I'm showing you, what I want to do is contrast local access versus S3 access. So this thing is churning along. Over here, the blue screen, by the way, is IP traf. So you can see there's no network activity because everything is local, right? This collection is all localized. All the data is on the disks, and really, there's two things going on. There's a lot of I/O going on, and there's a lot of computation going on. So why is there computation? Because really, what I'm doing, this is the command that I'm running. Okay. So what I'm doing is I'm going over all the collection, and what I'm doing is looking at everything that it happened after August, and I'm going over this full SQL, and I'm running a regular expression on it, looking for sticks and stones may break my bones, simply because I know that's not in um, any of these texts. So it's kind of the worst case scenario, right? If it's never there, it has to go over every single data field inside the collection. And then what I'm doing here at the beginning is I'm just setting a variable to say when did this start, and I'm setting a variable to say when did this end, and then at the end I'm going to compute how long did this thing take. Okay, and you can see it's completely consistent, and now it finished. Okay, so it finished in 162 seconds, and you can see the minute it finished, right, the disk utilization goes to 0. There's no reads anymore. There's no compute anymore, right? This thing went down. Okay, so now I'm going to start the second query, which is going to be very, very similar. Okay, the difference is instead of running, it's actually the same query. That's the whole point, right? It's the same date range, and it's the same regular expression range, and really the the difference is that this collection is local collection, therefore it hit the disk. This collection, on the other hand, is a cloud collection, so it's really sitting on S3. And what you can see is indeed there's no I/O. Instead, there's a lot of networking. Okay, so the difference is, um, to a user, this is fully transparent. It doesn't matter where the data lives. The system knows that if it's an S3, if it's S3 data, it just accesses it natively using S3. And what you can see this is at about 200 uh, megabytes per second, right? And which multiply that by 8, you get to like 1.5 gig per second. So it's actually amazing throughput for a machine that's very, very small, very inexpensive. There's nothing, nothing we ordered special. The other thing you can see is that the CPU is slightly higher than when it was local I/O, simply because of all these optimizations that we're doing in the back end, right? If you just access S3 directly in a naive way, you're never going to be able to get this utilization out of the network. Um, so we do all kinds of clever things in 3.1 that allowed us to get to this level of speed. Um, and I'm just gonna let it run until it finishes. And again, because I have this, I took the time at the beginning and the time at the end. I'll have the total time once it's finished. Um, the other thing is the other thing I can show you while we're waiting um, um, is right, the policy that is behind this, um, I mentioned that that this is running on S3. You can see here, this is it's called Sonar GD to Cloud, and it's an S3. It's an Amazon AWS, and this is where you configure kind of where do you keep the data for how long. In this case, I'm keeping the data for 3 years, and after 3 years, I'm going to purge this. And again, because um, this is intentionally a cloud-only collection, then I'm purging it from local. Okay, so let's let this thing finish just so we can see um, how long it took and what the delta is between a fully local EBS access. And again, from a cost perspective, the difference between S3 and EBS is very large, right? It's like 5 times cheaper to keep data on S3. It's very convenient. It's very resilient. Um, the minute it's on S3, then we can have stateless compute nodes, which can further parallelize the query and run it even faster. Um, okay. Okay, so it's done. You can see it finished, and you can see it is larger than the local, but again, if I do 237 minus 162 over 162, it's about 46% slower, right? And if you look at where we were before 3.1, it would be probably twice as slow or 2.5 times as slow. Um, so even with zero tuning, zero kind of anything special, we're now at a point where we're about 40% slower if the data is on S3 versus an optimized SSD-based EBS with a RAID array. So that's pretty incredible. Um, the other thing is there's a lot of tuning that we could do in terms of the optimizations we had for cloud storage. The number of prefetch threads, things like that. So we can actually get it lower than this 46%. We've seen numbers where we could be 20% slower than EBS. We've even seen cases where we were as fast as local disks. Um, and this is, by the way, not just for Amazon and S3. This is true for all the cloud platforms that we support. So it just means that you can get a really great data lake or data cloud for all your security data at very, very low cost um, and with a great architecture. So that's it. For more information, go to jsonar.com. Thank you.